Welcome to Talk Direct in Lee Digest. My guest today is Sri Padu S. Padmanabhan, a well-known expert in energy management both within and outside India. He was the former program director of the South Asia Regional Initiative for Energy and was also a senior energy advisor for USAID India bilateral program. He has served with the World Bank as an energy efficiency specialist and was a visiting fellow with the King Abdullah Petroleum Research Center at Riyadh. He's a recipient of several national and international awards in energy management and energy efficiency. So, Sri Padu, welcome to Talk Direct. It's such a pleasure to have you with us today. So I start with my first question. Recently, you received the Regional Energy Manager of the year 2019 award, instituted by the United States Association of Energy Engineers. This is quite an achievement. Can you explain a bit on the background of this particular recognition?
Good afternoon, Sharif, and thank you very much for your warm words of introduction. The AEE, the American Association of Energy Engineers in the United States, recognizes the contribution of individuals and institutions in the area of energy management globally. They have 1 or 2 awards per continent. And I was fortunate enough to receive the Regional Energy Manager of the year 2019 award for South Asia in recognition of my work in energy management, particularly in energy efficiency, renewable energy, and clean energy. But I'd like to hasten to add here that it was not my contribution that was recognized as much as the contribution of my partners, institutions I worked with for over 4 decades. So in a sense, AEEE also recognized them.
I suppose your career itself will be a good reflection of the early energy management efforts in India. In fact, you would have been in the first bandwagon of energy specialists in the country. So can you briefly tell where India started and how it has evolved, energy management, how it has evolved in the country during the past 4 decades or something?
Yes, I will. It's a long story of unsung heroes and institutions, but I shall be brief. It was in the early 60s that there was a recognition in India that one needs to look at energy more holistically, so as to optimize energy supply. And while doing so, also look at the other side of the energy equation, and that is energy demand.
Okay.
So it was in 1968 or thereabouts that the government of India came out with what is known as the Fuel Policy Committee report, which looked at the sector holistically, looked at options in terms of power generation, in terms of coal and coal management, and oil and imports of oil and indigenous production of oil, and renewable sources of energy. In those days, it was called non-conventional sources of energy.
Yeah.
And while doing so, they also looked at the demand side by looking at the energy intensity of the Indian economy. For the first time, macro indicators like energy intensity calculations were employed. And based on that, the Fuel Policy Committee report made an attempt to come out with a holistic design approach, which actually was the basis and the foundation for energy management in India. And that moved further to identify what they called in those days as fuel efficiency.
Yeah.
The word energy efficiency was not known, but it was the word fuel efficiency. Yeah. And there is a small story behind that, if I may, which I could elaborate a little bit.
Yeah.
See, the area of energy efficiency was introduced in India quite accidentally.
Oh, I see.
It was actually the textile industry in Mumbai which had a problem. in the mid 80s, in the mid 60s rather. They were using coal, and they had very little storage space to store the coal because coal occupies a lot of space, and in Bombay, space was a premium then, and as it is now for sure. So they wanted to look at solutions to that problem. Besides, coal had to come from Bengal, Bihar, and had to come in railway wagons, and wagons were in scarce supply, and negotiating over the steep gradient of the Ghats, the Western Ghats, was always a problem. There were accidents. So coal supply to Bombay and its receipt was hampered. So the textile industry was at a quandary. At the same time, in Bombay, you had two refineries, Burma Shell and Esso, and both the refineries had excess of what is known as heavy bottoms or furnace oil, which they wanted to market. And what better to market than to the textile industry who were their neighbor?
Right.
So, but Indian industry at that time had very little experience with fuel oil. So they did not know how to use fuel oil, and textile industry was in sixes and sevens as far as using fuel oil is concerned. So the Planning Commission was seized of this problem. They approached the National Institute of Fuel Efficiency Services of UK, which came to India, partnered with the National Productivity Council of India, established a fuel efficiency cell, and this fuel efficiency cell provided support to textile industry and beyond on how to use fuel oil, how to combust it, how to handle it, and so on and so forth. And NPC was in a position to be of assistance to the government of India when the oil price hike of 1973 took place, and this fuel efficiency broadened to look at industries all over the country. And there was partnership between NPC and the oil companies, which established the Petroleum Conservation Research Association, which even to this day provides strategic support on fuel efficiency and energy efficiency of petroleum products in the Indian economy. So that's the genesis of energy efficiency in India.
So a lot of work was actually done during that time, right? Like 4 decades ago. And where are we now?
Well, a lot of work has happened, and the coinage has also changed. At that time, as I said, it was fuel efficiency, and then we moved to using the word energy conservation, and under the guise of energy conservation, there were several strategic studies. Famous one was in 1982, known as the Interministerial Working Group on Energy Conservation, which was headed by the Ministry of Heavy Industry, but the secretarial services were provided by the National Productivity Council, and that laid the foundation for energy management more broadly in the country, in the sense that the Energy Management Center was set up, which today has resulted in the Bureau of Energy Efficiency, which is the apex organization which actually manages the energy conservation efforts in the country. Then from energy conservation, we moved to energy efficiency, and now we are knocking on the doors of energy productivity. So there's been an amazing amount of change, and Indian industry has adopted energy efficiency rather well. And energy efficiency has now become part of the institutional structure and corporate structure of Indian industry.
What's the current global trend and the areas of focus, especially in countries like the US, for instance?
What is the current global trend and what is the areas of focus? In the US, to begin with, and then later other countries, the global trend is to move towards net zero and to achieve net zero emissions by 2050. Now, what this means, net zero America, for instance, would have several interlocking facets to it. Front and center would be energy efficiency. And electrification, but electrification through renewables such as grid solar and grid connected wind, as well as biomass. And also systems to ensure that the inconsistency of renewable energy is kind of taken care of by better balancing. So there'll be a lot of developments on network designs and so on. And there would be focus on carbon capture and storage.
I see. Yeah.
Where you use fossil fuels, you could capture the carbon dioxide and store it, utilize it, and so on. There would be focus on non-carbon dioxide emissions. There'll be a lot of focus on biofuels, which will be hydrogen-based. So there'll be a focus on the hydrogen economy.
Yeah.
And there would be also focus on land sinks as forest remove the carbon dioxide from the ambience. So these are the 5-6 areas where there would be a lot of focus, including energy storages, electric vehicles, and so on. So this is a very exciting time, and work is going on in all these areas. And in different countries, there are different kinds of facets, although falling under the rubric that I just mentioned of these 6 or 7 facets. For instance, the ASEAN countries, the 10 countries of the ASEAN are looking at integrated grid, where they would actually generate renewables and export it or import it, as the case may be.
Okay. Yeah.
India has the most ambitious renewable energy generation program in the world, planning to add 175 gigawatts by 2022, well on its way to do so, and 450 gigawatts by 2030. So India's program is extremely ambitious, and they're moving swiftly towards meeting these targets.
If you go back a bit, in the 1980s, you worked with the USAID, and later on you worked with the World Bank as an energy efficiency expert. So can you tell briefly, like, what were the assignments and what was the outcome?
Well, Shri, you're taking me back to more than almost 4 decades.
Yeah.
Yes, I did join USAID in the mid 1980, but I had at that time almost 10 years of experience with the National Productivity Council in industrial energy efficiency, training, consultancy, and so on. USAID, India's bilateral energy program, was quite strategic, and it had 4 components. The first component was science to science exchange. You see, at that time, there was interest in Indian scientific institutions, national laboratories, academic institutions to partner with similar research institutions in the US. And USAID supported such science to science exchange in the area of renewable energy, in the area of clean coal, and in the area of energy efficiency. The area of clean coal deserves some mention. What AID's intention was really to help Indian manufacturers of public utilities, such as power plants, like BHEL, to understand Indian coals better, so that the design of the boilers could be such that they could burn Indian coals more efficiently. And that led to a USAID program working with NTPC to establish what is known as a Center for Energy Efficiency and Environmental Protection in Delhi, which has enabled NTPC to actually improve the efficiency of its operations. Of course, with BHEL, there was a lot of fundamental research on coal, which was supported by AID, such as fluidized bed combustion, coal gasification, and so on and so forth. When you have science to science exchange, what comes out is a product which may not meet the needs of the marketplace. It's exciting and interesting, but it's generally in a basic area. So we recognize that you had to develop institutional alliances between science, between the world of science and the world of enterprise and the world of finance. And in India, these 3 were all like ships passing silently in the night, not talking to one another. We had a program known as PACER in 1987, program to accelerate commercial energy research. And the purpose was really to help the Indian government, in this case, the Ministry of New and Renewable Energy, to actually allocate its research rupees into market-driven technologies through a public solicitation process in partnership with a development financial institution, which is ICICI. So with these entities like ICICI and the government of India going out for proposals from the marketplace to help support a technology to be developed and designed and commercialized was something new in 87. It was actually a forerunner. It was actually a forerunner to venture capital and angel investors and so on, who came much later.
Yes.
So the first VC program in the energy sector, venture capital, was actually an AID supported program called PACER. Much later, in 2005 or thereabouts, or actually thereabouts, USAID worked with the Indian private building sector and developed among the world's largest green building movement. Starting with a 20,000 square feet building in Hyderabad, which was the first platinum awarded building in India, because these awards are given by the US Green Building Council. Today, India is around 7.8 billion square feet. But that opened the doors for the establishment of the Indian Green Building Council, which today has more than 50 offices all over the country and has tens of thousands of architects as members. And today, as I said, the Indian Green Building movement is number 2 in the world. The US is the largest, but India is slowly catching up. And the reason is very simple, Sharif. 70% of the buildings in the year 2030 are yet to be built in India.
Yeah.
So there's a lot of work to be done.
Now, we were having energy audit in the industrial sector since the 80s in a very strong way. And I don't know, I mean, do you think that much of the manufacturing sector is sort of complacent with the fact that they're doing energy audit and that's the end of it? And in the entire gamut of energy management, where does energy audit component fit in, and what percentage of meaning and value for that?
This is an excellent question. Indian industry has taken to energy audit like a duck takes to water.
Yeah, absolutely. Yeah.
And we have developed the energy audit function to a point where it's quite sophisticated with instrumentation and so on, and with data analytics and so on. But the fact of the matter is that energy audit is only a way station, is not a destination.
Not a destination.
And energy audit identifies opportunities, ranks these opportunities, but it doesn't do the implementation. You still have to do the implementation. So what is really missing is measurement and verification as a discipline and as a science. And that has taken a long time to evolve. So in our hurry to do energy audits and to make energy audits mandatory, there was also a feeling that energy audit is by itself sufficient, but it's only the first step in a long journey. And if you have a measurement and verification system, then you can be sure that energy is saved, because energy cannot, Sharif, be metered. It can only be computed. You need a before and an after.
Absolutely. Yeah.
And MNV measurement and verification will tell you your baseline, and then will tell you how you have improved upon your baseline through the interventions that the energy audit suggests. So an energy audit is important, it's necessary, but it's not will not result in energy savings. In fact, there are many industries which have conducted energy audits, but have not gone beyond the energy audit. So that, I think, but that thought is now sunk in, and today measurement and verification as a discipline is slowly catching up.
Okay, very good. So, then that brings me to another subject which you often handle, which is the water energy nexus. You had written in Lead Digest about water energy nexus, which has widely been read now. But for the advantage of the viewers of this particular program, can you highlight what is the real pain point in water energy nexus in the context of India, particularly?
See, co-management of water and energy is critical.
Yeah.
You need water for energy and you need energy for water. You need water for energy because if you have to generate energy, either in a conventional thermal power plant, you need water,
Yeah.
or in a hydro plant,
Yeah.
which moves because of the kinetics of the water flow.
Yeah.
You need energy for water because if you have to convey water, you've got to pump water, you've got to treat water, you've got to recycle water, you need energy at all these stages.
Yeah.
So water and energy are interdependent and close together. Now, there are certain points where the water energy is a pain point for the economy. And I'll give you an example in India. See, if you look at the agricultural sector, almost 50% of the water is from groundwater, and the balance is surface water and rain-fed agriculture. And groundwater is from deep bore wells or surface wells, and this requires pumping power. To pump the water, you need electricity. And almost 30% of the total electricity in the country, agricultural states, the states which have large amount of agriculture, which is the northern state and some of the central states and the southern states, almost 30% of the electricity is for agriculture, is used in the agricultural sector. Now, for a variety of reasons, because of inefficiencies in the pump sets, because of indiscriminate pumping, a lot of the groundwater levels have been falling. I've often said that the fate of the Indian power sector lies in how water is managed and used and priced. So what's actually happening is a vicious cycle in many parts of the country, where wrong choice of equipment, where inefficiencies in distribution of power, where inefficiencies in the pumping system, and not looking at water conservation and management in tandem with the network design on the electrical side has resulted in a very vicious cycle. Now, how do you make that into a virtuous cycle? It can be done, it has been demonstrated, but it needs to be scaled appropriately in the country.
So that calls for a holistic or integrated approach which has impact on various other sectors, right? Like we need to have a holistic approach, not from an energy management point of view.
Yes, it needs a holistic approach. And let me just try to answer that question in the context of what I had said earlier. If you need to move from a vicious cycle to a virtuous cycle, you need to look at water and energy together. Now, in a practical sense, if you were to go to a rural area and go to a rural substation which has which is distributing electricity, you would find a particular pattern. And the pattern is basically this. There is a transformer which is located in the middle of the village. And from the transformer, lines are drawn for energizing the pump sets. But the same line is also used to energize lights and other requirements of electricity. So it's what is known as a mixed feeder. The length of this line is very long, running into kilometers, whereas the voltage is low. The LT by HT ratio, that is low tension by high tension ratio, which should be 2:1, 2 kilometers of low tension to 1 kilometer of high tension, is sometimes 8:1 and 10:1. That results in line losses. It results in voltage drops. When the voltage drops and it goes to the farmer and he has a pump, he tends to go in for a larger size pump. He also tends to protect his pump from burnouts. So he uses thicker windings. Essentially what happens is that there's inefficiencies built right there. Also, since power is only available for 4 to 6 hours a day, whenever power is available, the farmers all put on their pump sets at the same time. So there's overload on the transformer burns out. So it's a vicious cycle.
It's a vicious cycle.
And there's a tendency to pump as much as water because you're getting power only for a few hours.
Even if they don't need it. Even if they don't need
Even if you don't need it, you end up pumping more, etc., etc. Now, how can you convert this into a cycle which is virtuous? It can be done. It can be a business approach. It's a win-win situation. You can go into high voltage distribution systems. You can have transformers which are very close to the pump. You can have segregated feeders. You can have high efficiency pump sets. And you can have irrigation, water efficiency methods such as drip irrigation and sprinkler irrigation and so on and so forth. There are ways to conserve on water. So that's the kind of holistic approach that one can use to relieve this pain point. This pain point is painful to the farmer. It doesn't help the utility because they don't get paid because it's subsidized power. And it's a pain point for the state government because they have to subsidize it and use up scarce money from the exchequer to pay for the losses, whereas they could use that money for health and education and other social sectors. So this is
it's basically it's high time that we come out of this compartmental approach in in providing utilities and things like that.
And there is also another compartmental approach that we have towards industrial energy efficiency. I've had discussions with several captains of industry, and the question that they've asked is, we have done so much. Are we getting enough savings? Can we get further savings? Yes, indeed, you can get about 25 to 30% more savings than what your system allows you for, provided you follow an integrative approach. There is a tendency, if you map the energy efficiency technologies which are in use in industry, whether it's Indian industry or industry anywhere, they fall under what is known as 4 quadrants. The first quadrant is something that we learned in NPC long time back, and that is housekeeping measures or first aid measures. And most people know about it, Indian industry knows about it, so let's not talk about it. The second quadrant is what is known as must-dos. These are measures which have a return of investment 2 to 3 years. They involve things like insulation, high efficiency pumps, things like instrumentation and control, boiler combustion efficiency, and so on and so forth. But these are isolated, standalone measures. The third quadrant is what I call as integrative technologies, and I'll come to that in a moment. And there's the fourth quadrant, which is transformative technologies. That's like circular economy, nanotechnology, digital. Still far away. It still takes some time. So let's not talk about the fourth quadrant. Indian industry is knocking on the doors of the third quadrant. They are basically done the must-dos. Can do a little more, but nonetheless, they're well aware of it. But they are knocking on the doors of the third quadrant, which is an integrative approach. And in integrative approach, you have technologies such as pinch point technologies, integrative pumping technologies, cogeneration technologies using advanced heat power, and so on. But the point is, what is stopping them from moving into integrative technologies? Let's take a very, very simple example, such as insulation of a pipe. This is well known. Everyone knows the pipe, but you insulate the pipe based on what is known as minimum economic thickness. Let me wear my economist hat for a moment. You insulate the pipe where the marginal cost of investment is less than the incremental savings in energy. The moment the marginal cost of investment is greater than the cost of saving energy, then you will stop. You have reached the cost effectiveness limit. However, by insulating the pipe, you have also actually downstream, as far as the boiler house is concerned, as well as the piping is concerned, you have actually reduced the size of the boiler notionally, because you have less amount of heat transfer, because you have saved on heat along the way. So you can go in for a smaller system. That is, you can not only reduce OPEX, which is fuel cost, you can also reduce CAPEX. Give you another example. This is a very typical example in many industries, what I call as small pipes, big pumps.
Yes.
Pipes are small, head loss is greater, friction loss is greater, pumps are large. Why don't you go for big pipes and have a smaller pump? Smaller pump means capex savings, energy savings. Lighting is a third example. Many a time, a lot of attention is paid on choosing the lamp with the highest lumen efficacy. You want to go for LEDs and so on. But that is important, but is the lighting up the task at work?
Yeah, absolutely.
Maybe lighting up everything else other than the task
Other
at
than
work.
the task, yeah, other than the task.
So overall task efficacy could be very low.
Yes.
Your task efficacy is a function of light efficacy and application efficacy.
Application, yes, absolutely.
So if this is high and this is low, that overall task efficacy is low.
Yeah.
So you can. So these are very simple examples, but then one looks at industry.
Yeah.
Can find that there are opportunities by integrative design, which
integrated design, yeah, absolutely.
And industries, by and large, internationally as well as in India, have not done enough in this area.
Now, when we think about the energy use itself, how do we connect this energy use with the outcomes of this energy use? Like if you think in terms of the value addition, the GDP, and so on and so forth. And what do you really get? What is the net, net positive result out of that? I mean, can you throw some light on that thinking?
Again, Sharif, this is a very perceptive question, I must say. Typically, when we talk about energy use, we use the term, how is energy used? That's a very typical question which is asked by managements. How well am I using energy? And the answer is straightforward. We do an energy audit. We identify conservation opportunities. We rank those opportunities. We implement the most promising ones in terms of techno-economic returns and so on. And end of story. But if you ask the question, what is the energy used for? Then you open up a wide array of questions and issues. You look at modernization, you look at restructuring, you look at issues related to value addition, and so on. Now, the term energy productivity is what I'm arriving at. And it is the economic value of a nation in a year divided by the total energy consumed. For a company, it is the revenue generated in a year divided by the energy consumed that year. Now, energy productivity and energy efficiency are two different approaches and two different issues. While energy productivity is focused on value addition, energy efficiency is focused on energy savings. Energy productivity is a top-line investment issue because modernization and restructuring and so on and so forth require investments. Energy efficiency is a bottom-line issue. Energy efficiency improves your bottom line. Energy productivity improves your revenues and profits. So what does this mean? You've changed the goalpost. The moment you talk about energy productivity, you've changed the goalpost. What does it mean? For instance, let me take three sectors and very quickly I'll explain it. Aluminium, paper, cement. These are three key industrial sectors. Now, do you want to manufacture aluminium? Go all the way from bauxite, manufacture alumina, manufacture aluminium. or do you want to go all the way and manufacture airplane fuselages, which will add much more value? Do you want to manufacture stationery paper, or do you want to go all the way and manufacture specialized paper, tissue paper, and so on and so forth? Do you want to manufacture pozzolana cement, or do you want to manufacture specialized cement? Remember that the energy inputs for manufacturing a specialized product is not much greater than an energy input manufacturing the basic product. So with the same amount of energy, you add a lot more value. And that's what energy productivity is really all about. Now, if you were to look at India and look at China, without a doubt, energy intensity and energy productivity has changed over a period of time. And see, energy intensity is the inverse of energy productivity. So if you have declined in energy intensity, it means your energy productivity has improved. India's energy productivity between the years 2000, the years between 1990 to 2015, because that's the period I had an opportunity to study quite closely when I was at CAPSAC. In the 25-year period, India's energy productivity has increased by almost 78% to be very specific between these 2 years. China's has also increased by 210%. Now, the question is, how did China's productivity improve so dramatically? Now, energy productivity improves through two methods. Energy efficiency does improve energy productivity. Don't get me wrong. Energy efficiency is a subset of energy productivity. Energy efficiency improves energy productivity. But structural changes in the economy improve energy productivity a lot more. So China reduced its energy intensity by 5% per year between 1990 to 2015. India reduces energy intensity by 1.8% or improved its energy productivity by 1.8% during the same period. But India's energy intensity reduction or energy productivity improvement was largely due to energy efficiency and less due to structural changes. Whereas in China, the largest reduction in energy intensity anywhere in the world, year upon year of 5%, was largely due to structural changes and less on it. So it's time that we move to energy productivity as an indicator of how energy is used, which will actually evaluate value addition and so on and so forth through diversification, modernization, restructuring, etc. And I think the moment that we use energy productivity as a basis to move forward, then a lot of other connections between energy productivity and climate change and others will all come out very starkly and clear.
Coming back to this energy efficiency, I mean, it'll be good for the viewers if you could sort of reiterate like the core benefits at a societal or community level, at the industry level, and at a macro level. So, is that
interesting question? And see, at a societal level, energy productivity, energy efficiency has a definite connection with health and labor productivity and things like absenteeism. Let me explain. If you have a green building, and today there is sufficient evidence to show that a green building definitely improves indoor air quality, and improvement in indoor air quality has an impact on employee health, employee productivity, employee reduction in absenteeism, and so on and so forth. So one can make these connections. These are what is known as the co-benefits of energy efficiency. In fact, the decisions to go in for green buildings in India by corporates have less to do with energy savings. They're more to do with improvement in labor productivity, which is a very interesting change. Today, the cost of a green building is no more than a cost of a regular building. Green building costs have come down. But yet management sometimes are reluctant to go in for green buildings for whatever reason. But when you make the case that this green building will improve your labor productivity, reduce absenteeism, improve health of your employees, they get interested. So at a societal level, the core benefits such as these are important. The second I thought you said was in the industry. In industry again, time and again, NPC actually talked about it 30 years back. P.R. Srinivasan and others talked about it 30 years back, that efficiency will save you fuel, but efficiency improvements will also improve product quality.
Yes.
See, if you look at engineering industry, furnaces, etc., the product quality which goes through these systems improve tremendously, rejects are reduced. At the macro level, and this is where it gets very interesting, and I touched about it when I talked about agricultural productivity, but let me expand on that because it's a very important point. Today, the issue is reduction of the fiscal deficit in countries like India, and reduction of fiscal deficit at the state level, at the national level. Now, if you take a state in India, 10 to 15% of the fiscal deficit is largely due to the subsidies given to the agricultural sector for paying for the losses incurred by the utilities. See, the utilities which supply power don't get much by way of tariff from the farmers. Farmers either get free power, as in Tamil Nadu, or they get power at a very subsidized rate. So the utilities lose out on that. So what does the utility do? They increase the tariff for the other customers like industry and municipalities and homes, so as to cross subsidize the losses. But you can't cross subsidize all the losses, because then the other tariffs will increase and industry will just either not come to your state or they'll set up their own generation systems. And you don't want to do that. You lose them completely. So there is a balance. The government gives a direct subsidy to the utility in order to cover the losses. So some losses are covered by cross subsidy, but a major portion of the losses are covered by direct subsidy. Now, if you were to have an efficiency program and reduce the losses, in effect, you're reducing the level of subsidy that the government will have to give by way of intervention, and therefore you are playing a role in reducing the fiscal deficit. Let me end with this point. The value of the losses made by the Indian power sector is double what the country spends on health and half of what it spends on education. So if you reduce those losses, can you imagine the number of schools that we can build, the number of hospitals that can be set up, etc., etc., etc. So there is a huge macro level impact of energy efficiency. And I can make the same argument in terms of impact on petroleum fuels also. But I think you get the drift of what I'm trying to say.
Absolutely. That's a very interesting point. In fact, I think many countries face this issue, right? They subsidy.
Many countries face this issue, subsidy.
Now, you have also written substantially about the need for deep decarbonization, especially in India. Can you just sort of clear the jargon and then
Yeah. See, you asked me a question earlier on about what is the direction in which the clean energy movement is going to take place, and I mentioned about the US, and I talked about 6 facets. I talked about energy efficiency, electrification. I talked about fuels that are less carbon intensive, hydrogen, for instance, carbon capture and storage, and so on and so forth. See, all of this is moving towards this end goal of deep decarbonization. Decarbonization means less carbon in the fuel, and less carbon in the fuel means less CO2 up in the atmosphere when you burn it. But that heat given by carbon has to be replaced by something else. Electricity could be one, but electricity generated from renewables. See, the question is, and I'm referring to an earlier comment I made, that many countries are now moving towards more and more renewables. India is going towards 175 gigawatts of renewables and so on and so forth. These are all steps in the right direction. It's all part of deep decarbonization. But you need to work on both sides of the meter. What is not generally well known is more carbon is generated in India on the demand side of the meter than on the supply side. Now, this is, and what that tells you is supply side fuel substitution from fossil fuels to renewable is very important. The demand side of substituting fossil fuels with renewables is also equally important. But industries cannot run on renewables like solar and wind completely. I mean, you can use solar for power and you can use that power. But if you use that electricity generated from renewables and generate hydrogen through electrolysis and use that hydrogen as fuel, or use that hydrogen as feedstock to make biofuels, then you can substitute furnace oil and coal and so on and so forth. This is all part of the decarbonization process. Now, to get all these things to come together, it requires different coupling of what I call sectors and subsectors. The Germans call it deep decarbonization. Another term is sector coupling. And that's what we have to move towards. Also, I think and this is, I think, an important point, and somehow I missed making it. Net zero India.
Yeah.
That is, eventually, at the end of the day, we consume, we do not generate any additional carbon dioxide into the atmosphere. Whatever carbon dioxide we send into the atmosphere, we have leached it out of the atmosphere through our sinks, through our forestry programs. Now, obviously, deep decarbonization also requires a huge forestry program to act as sink.
Yes.
It requires efficiency programs. It requires fuel substitution programs, such as renewables. But the interesting point here is this. When you look at the curve of carbon emissions in a country like India between now and the next 50 years, and if it's business as usual, then our carbon emissions is going to increase by leaps and bounds. And the overall objective, which is a global objective of keeping the global temperature rise within 2 degrees centigrade in order to keep climate change under control, with an aspirational objective of 1.5 degrees centigrade, because 2 degrees still there will be a lot of mishaps which will happen, and a lot of issues related to flooding and rise in sea water levels and so on and so forth. But bring it down to 1.5 degrees centigrade, which is what now the terminology is moving towards. You would have to do deep decarbonization, of which there would be the elements that I mentioned. But the one which will reduce carbon the most to meet your objective of deep decarbonization by 2030, so that your global temperatures do not go above 2 degrees centigrade, is energy efficiency. 45% of the total carbon reduction will be through energy efficiency, energy productivity, and all of that that I earlier mentioned. And the balance 55% will be through renewables and through carbon sinks and all of that. So that's why energy efficiency is so important. For us to move, it has to be center stage. So I would conclude by saying that energy efficiency would be the first fuel.
Yeah, absolutely. Yeah.
Fuel. It's fuel.
It's the first fuel. That's an interesting conclusion. Yeah.
Yeah. And we look at energy efficiency not only in terms of energy savings and being a first fuel, we also look at it in terms of the co-benefit that it brings along with it. And to move from an economy which is dominated by fossil fuels to an economy that's dominated by renewables, energy efficiency is the bridge, and will always. And both efficiency and renewables are two sides of the same coin. You need efficiency to meet your renewable energy goals. Institutions are making this change. Energy efficiency is front and center for decarbonization efforts the world over. Net zero America or net zero India, energy efficiency is recognized as the first fuel. So there is now a much better understanding than before. Now you got to convert all these sentiments into action and into implementation, and to scale. To do it at scale is important. We have done it in bits and pieces here and there, but now to do it at scale is where the challenge lies.
Thank you. Thank you very much, Mr. Padu, for your valuable time. but for very insightful conversation. I'm very sure our viewers will be more than benefited by just listening to this roughly about 20 or 30 minutes of the program. We look forward to more specific discussions with you on this platform in the coming months. So thank you very much once.
Thank you, Sharif, for the questions that you fielded. The questions are well articulated, they're well conceived, and it was a pleasure talking to you.
Thank you very much. Thank you.